Okay. Yeah, I can. Okay, here we go. So state in simplest form and non-permissible values. Questions that you're going to see on the review are just like the ones on the test. We'll see about question 6 when we get to it. I haven't decided yet what I'm doing. Okay, look at the first one. You should be able to tell right away. The binomial on the top, what about it? Difference in squares. You should see that right away, guys. So 5, 2x minus y, 2x plus y, right? What about the bottom? Does it factor? Guys, more than likely, if I give you something, is it going to factor? Yeah. What do we get? 2x and x, obviously. Now, the 8y squared is the one that's going to throw you. Could either be 1y and 8y, or 2y and 4y. It's not 2 and 4 in this case, because you got to get to 15. So what is it? 1 and 8, because you need 16 and then minus the 1. Right? So it's going to be 8y and, nice 8y, as I write down a 2. 8y and y, and we want it to be negative, so the negative is going to go there. Okay, what do you notice? You can cancel, right? Now, why can we cancel again on this one? Because they're all multiplied, right? That's what makes the difference. So we end up with 5 over 2x minus y over top of x minus 8y. Okay. Now, this is the one where the NPV is tricky. Why is the NPV tricky on this one? No, because there's an x and a y, right? In the other ones, there's just been one variable, right? Put those dice back, please. Right? So this is the one that's tricky. So how do you write this out? Now, there's going to be two NPVs, right? This one and this one. So we're talking about NPVs. Well, basically take whatever it is, 2x plus y, make it set it equal to 0. Now, before, right, there's always been there's just been one variable. Now there's two. What do you want to do? Do you want to do x or do you want to do y? It really doesn't make any difference, right? X is funner, okay? Okay, so we move that. So 2x equals negative y, x equals negative a half y, right? Is that right? Or y over negative 2, or y over 2, sorry. And that can't be right, so we put that. What's the other one? 8 minus x, x minus 8y equals 0. X equals 8y. Oh, that one's already in that form, isn't it? Those are the tricky ones, right? Because they have two variables. But really, is it really easy? Just set it equal to 0. You know how to do that. This question for your NPVs, you could either give me them in the form of x, or you could give them in the form of y. Now, guys, would you do something dumb and give me one in the form of x and then one in the form of y? No, don't do that. Like, if you give this one an x, make sure this one is an x. Don't do them one of each. Yeah. That's really quite an easy question. Test question? Oh yeah, definitely, right? They're all, I mean, I don't know if you noticed that, the questions I put on the reviews are really, really similar to the test questions. In fact, sometimes they've been the same.
A lot of the time.
I know. No, I know. It's just sometimes you guys miss the boat. Okay, you got two functions. You got f functions and a g function, right? You know what f of x means. What does f of x mean? It's y. G of x means y. The reason we do that is because you can actually then have two different equations. Because if they're both y equals, I'll say, hey, the y equals equation, do it, right? You wouldn't know which one to do. But if I say the f of x equation or the g of x equation, you know which one to do. What I want to know is, are these two equivalent? Well, this one here is already in trinomial form. So we're not going to change that. What do you notice about the f one? Could we actually FOIL all this out and distribute and see if it's the same? Yeah, let's try that. Okay, so f of x equals x plus 2 times x plus 2. Do not make the mistake like you make on your mental math sometimes, where you put x squared plus 4. Don't do that. We're not making those mistakes anymore. It's two binomials, right? Minus 5x minus 3. Okay, so let's do this. So f of x equals, we'll do this one, x squared plus 4x plus 4 minus 5x plus 15. Now what do you do? Combine everything. Correct like terms, right? CLT. F of x equals x squared minus x plus 19. Is it the same? Are they equivalent? Yeah, you just proved that. Should have done this ahead of time. So what good does it take you copying it down?
Well, I learned how to, yeah, that's what I did.
Right.
But we went through the steps to make we should do it beforehand.
Hey, now you're thinking.
Oh, you missed one.
Hey! Are those equivalent?
Yeah.
Well, we don't know. So what do we have to do to g of x? We have to simplify. I see a trinomial at the top, so what do you think you're going to do? Factor it, see if anything cancels. Okay, so here we're going to do g of x. There we go. So g of x. We're going to factor this top part, probably into two binomials. What are the only two factors of 2x squared? 2x and x. What are the only two factors of 3? 1 and 3. This sign here in front of the 3 means they're both the same. We look in front of the 7, they're both negative. Okay, so where do we want the 3 and the 1? Okay, because that gives us 6 and that gives us 1, which gives us our 7. Okay, what's this all over top of? X minus 3. What can we cancel? G of x equals 2x minus 1. Are they equivalent? No. Please don't make that mistake. Like you'll see that the numbers are the same, but what about the sign? Different, right? Don't make that mistake saying that they're equivalent. We're done, right?
NPVs.
Oh! Does it actually say that in the question? Yes, it does. Guys, you got to read the question, right? Some of you are making that mistake when you do a test. You're not reading the entire question. You're just looking at it and kind of going off doing it. What's the NPV in this case? NPV is x cannot equal positive 3. Because if you plug positive 3 into that, 3 minus 3 is 0, right? Undefined. So that's why it can't be 3. That's your buddy. Come there. Okay. Simplify each expression and state any non-permissible value. Standard question. We got to do both. You always have to do both. You factor whatever you can, whether top or bottom.
And then you times it up.
You got to multiply by the reciprocal. Okay, so there's a whole bunch of things you got to do in this question, right? So let's factor it for start. Actually, if you really get good at it, you can factor it and flip it at the same time, right? Yeah, why not? So 4x minus 1 over top of x and x plus 3 and 4, right? Is that right? You gotta get fast at that factoring because you'd waste so much time trying to figure it out. Now, again, you can always go back and check to see if you did it right or wrong, right? Before I let you go backwards. We're gonna do the flip right away. Okay. What about this one? X plus 4 and x minus 3. It's supposed to be a plus 4. Let me write that out again so you can actually read it. Now, because you're multiplying, you can throw it all together, right? All the top, all the bottom. Can you cancel anything? What can you cancel? Whoa, careful. The 4, but not the 3. right? That one and that one, right? Why can't you cancel the 3's? Yeah, one's positive, one's negative. So what do you end up with on the top? 4x minus 1 and x minus 3 over top of x plus 3, 2x minus 1. Right? Don't be surprised when you get something like that you can't factor anymore, that you can't simplify anymore. You actually, no. Why would you do that? It says simplify. So if you're trying to go back, you're trying to put it into a trinomial. That's not simplification. That's going backwards.
So you're done right there. That's what you did.
NPVs. Now, NPVs. You got to be careful in this one because there's more than you think. NPVs. What's one of them? Well, and, okay, so those are two there. So negative 3 and negative 4. 1 over 2, you got to do this one here, right? So you move it to the other side, the 1 goes to the other side, it becomes positive, so a half, right? So one of them is also a half. But this is where you're going to make the mistake. What? You have to go back up here. Before you flipped it, what was on the bottom here? Negative 4 and positive 3, right? Back up here before you flipped it. You have to include those ones. The only time you ever do that is when it's division, right? If it's multiplication, it's easy because it's just all the bottoms. But division, you have to deal with the ones that were originally before you divided it and then after it also. So you have to include these ones also. So negative 4 and positive 3. Now, did we already have a negative 4? So do we have to include it again? No. Yeah, you could do that too, right? You could do plus or minus 3 instead of doing both of those. That works also, right? Save yourself a little bit of time. If you're going to forget that, please write that comment down about the division, right? Look at the denominator before the division, and then look at the denominator once you do the reciprocal, right? Because it has to include both of those. Yep. Well, I'm giving you everything, right? What do we got? A plus question, a solve, and then 2 word problems. Okay. The addition question, what do you got to do? You got to find a common denominator. So to do that, before you can find the LCD, well, no, what do you got to do? There's no difference in squares. Well, there will be in a minute. But you have to factor it first. You have to factor it first so you can find the LCD. Right? You have to do that. Okay. So let's do, so 3x plus 1. What's on the bottom? No. What can you take out? A 2, right? So you end up with 2 times x squared minus, oh, what's that? Difference of squares. So what is that x squared minus 1? It's actually x plus 1, x minus 1. Okay, so I'm going to do that right now. I'm going to do that as, so x minus 1, x plus 1, right? Might as well do it. You need to break it down, all its pieces, right? Sorry? You can if you want, but, well, you can't factor the top anyways, right? There's nothing you can take out of the top. But the thing is, you can do it if you want, but we're doing addition. We're going to have to do some multiplying anyways. Okay, plus, what's on the top here? 2x plus 2. You could if you wanted to. Could you factor that top?
Can you take out a 2?
That's what I just said. That would be taking out a 2. You can if you want, but it's different. It's different because it's not multiplication or division, right? We're doing addition, so you can take it out. It may help you later on, may not. That's fine. What about the bottom? GCF, right? What are you left with? X squared minus 4x plus 3. Can that factor into 2? Yeah, both. What is it? X minus 3, x minus 1. Is that right? No. Oh, I'm going to do that in right now here. So x minus 3, x minus 1. X minus 3, x minus 1. Okay, so there's our bottom. Now, what do you got to do?
How did you get x minus 3, x minus 1?
Because I just factored into a trinomial and then I factored it into two binomials. Sorry? Sorry, what? Can't cancel anything. Why can't you cancel? It's addition. You can't cancel, right? It's only when it's multiplication or division. Write that note down, too. Well, you're making all the classic mistakes, right? That's what everybody else does, right? You cannot cancel unless it's multiplication division.
So you just take this comma from the top and cancel the 2 with the top part.
No, we're just doing LCD. Just hang on. Okay, LCD. LCD. What do we got?
2.
We got a 2. Common to both, so that's one of them. 2. What else? X minus 1, we have 2 of those, so we only need 1 of those. And x minus 3. And x plus 1. Oh boy, that is one big old LCD. It's a 3. Look right there. Justin, look. Come on. Oh my, you know what? So now again, you're wasting more of my time. I know what it looks like, but you know what it is because it's x minus 3. You know this. You guys always ask questions you know the answers to. Yeah, you might as well do them right now, eh? Do the NPVs? Sure, why not? Let's do that. So our NPVs, where are they? 1, -1, 3. So plus or minus 1 and 3. Okay. Why not? Okay, so what we're going to do is we're trying to put these two rationals over top of this whole LCD. Okay? So let's draw that out. It's a big LCD, right? So it's 2, what did we say it was? X minus 1, x plus 1, x minus 3. Okay, so there's our LCD. So look at the first rational. We have a 2, an x minus 1, and an x plus 1. So what are we missing? Which one of those 4 there are we missing in this first one? X minus 3. Okay, so we have 3x plus 1 times x minus 3, right? That's what the first piece is. Okay, look at the second one. We have a 2, an x minus 3, and an x minus 1. What are we missing from this one? X plus 1. Hang on. You got to look what you're missing, right? It's really quite easy because there's 4 things. It's going to be missing 1 in this case because there's 3 and 3, right? You can't cancel because of the addition sign. You have to combine like terms. But to do that, you have to do some foiling. Yeah, you got to foil this chunk and then collect like terms. And hopefully you end up with a trinomial that you can factor back. Yep. You don't understand how I got that top line? Okay. I'm trying to get my common denominator to be this, right? The 2, x minus 1, x plus 1, x minus, just please, x minus 3. Now look, here's the first rational right here. You see it? I have a 2, an x minus 1, and an x plus 1. What am I missing? I'm missing x minus 3. So I got to times the top and the bottom by x minus 3. So I times the denominator by that, or I have to do it to the top piece. So 3x plus 1 times x plus 3. Right? Yeah, x minus 3. Here, I have 2, x minus 3, x minus 1. Here's my common denominator. What am I missing? I'm missing the x plus 1. So I times the bottom by x plus 1, and I times the top piece by x plus 1. So 2x plus 2 times x plus 1. Yeah?
You didn't get the step where you wrote the LCD, right?
I what?
You get the step where you wrote the LCD above the other numbers, didn't you? About 3x plus 1.
That's if you're solving. That's if there's an equal sign. That's 6.4. That's a different lesson.
You have to time which top the one that is the next.
Yeah. Because you're basically, think of it this way, if you're trying to make, if you went to 1/2, right, a basic fraction, if you went to 1/2, right, and you wanted to create something with a base of 12, what do you times the bottom by? 6, so what do you times the top by? 6. Well, okay, look, we're trying to get this thing, 2x minus 1, x plus 1, we're trying to get it to have a denominator of this. So what did we times it by? X minus 3, so then we times the top by x minus 3. But we're just creating a rational, an equivalent rational, right? That's all we're doing. Of course, yeah, because if you're trying to do it differently if it's an equal sign because you're trying to get rid of the denominator. That's the difference. If there's an equal sign, which is the next question after this, right, on the review, right? You're trying to get rid of the, or you have an equal sign, so you try to get rid of the denominator. Okay. Now what do you do? FOIL. There we go. So 3x squared. So 3x squared, that's going to be negative 9 plus 1, so that's going to be negative 8x minus 3, is that correct? Plus 2x squared, what's that going to be? Plus 4x plus 2, is that correct? What? Same thing again. We have an x minus 3, an x minus 1, and a 2. We're trying to get a denominator. What are we missing? We're missing an x plus 1. So it's 2x plus 2 times x plus 1. Right? It's just another equivalent rational. That's why we have that there. Okay, did I do my math correctly? Okay, all over top of 2, x minus 1, x plus 1, x minus 3. Okay, what do you do to the top? What do you mean add? CLT, collect like terms. What do we got? 3x squared and 2x squared is? 5x squared. Negative 8x plus 4x is? Negative 4x. Negative 3 plus 2 is? Negative 1. All over top of this whole thing again. I'm tired of writing this out. No, do not write LCD. That's just lazy. Do I write it out? Yeah, I have a degree in mathematics. That's if you're solving for x. That's if it's an equal sign. No. Okay, what do you do on the top now? Yeah, you factor. 5x and x and 1 and 1. Where do the signs go? Positive, negative. Is that correct? Because that gives us our 5, that gives us our 1, that gives us our negative 4. Yeah. All over top of 2, x minus 1, x plus 1, x minus 3. Now, can you cancel? Why? Right, it's all multiplication, right? And that's the key, right? You can cancel now because it's all multiplication.
And now I feel more room.
You got lots of room on that page. So these two can cancel. What are you left with? What's on the top? 5x plus 1 over top of 2. Two, x minus 1, x plus 1, x minus 3. And did we already do our NPVs? Yeah, we did it a while ago. That's a good question, by the way. You're going to see one of those on the test. Well, not really. You just have to make sure you understand the steps, right?
We're going to be sitting here for like 16 days.
If you're sitting here for 16 days, you're in the wrong course. Okay. Now, this is the one, this next one is the stuff we did yesterday. No, this is what you were supposed to do for homework. So now you're wasting more of my time because you didn't do it as homework. Okay, that makes sense. Okay, solve and check. Now here, guys, this is the one that you all were trying to do. because there's an equal sign, what are you trying to get rid of? The denominator. But you still do the same. The denominator, yes. Not a denominator anymore, it's the dominator. Okay. This is where you're trying to get rid of the denominator, so you get that nice single line, right? So that you can solve it for x. But you still do the same things, right? You got to factor, find your LCD, right? The only difference is when you find your LCD, this is where you write it to the top left. Okay, so is there anything we can factor? No, it's already done it for us. Very nice. Okay. So what's our LCD?
X minus 1, X plus 1.
X minus 1, X plus 1. Okay. Hey, should we throw our NPVs in there anyways? Sure, why not? We'll live dangerously. So what are our NPVs? Plus or minus 1. Okay, now, this is where you write it out again, but you got to make sure you give yourself some room, right? Because we want to put our LCD on the top left-hand side of each one, right? But give yourself some room. Don't pack everything together like you normally do. So 5, x minus 1, over there, plus 2 over x plus 1 equals negative 6. Okay? So here we go. So I'm going to put my LCDs up the top. So x minus 1, x plus 1. X minus 1, x plus 1. X minus 1, x plus 1. You can do whatever you want, but I do the steps so I don't screw it up. You can skip to the next. Oh, we'll find out.
It's harder to factor, or it's harder to cancel then.
How is that harder to cancel? That's gone, and that's gone. What are you left with? Yeah, so 5 times x plus 1, right? I mean, that's why I do it that way. It makes it easy to see. And even if you don't understand what you're doing, it's just a series of rules. If you can follow steps, you can actually do math. You don't need to understand it to actually do it. That's the interesting thing about math. To understand how a computer works? You don't. Do you need to understand how a computer works? No, you don't. You can just do it. Okay, what's next? What do we cancel here? These ones and these ones. Okay, so then we end up with plus 2 x minus 1. Awesome. Equals negative 6 times x minus 1, x plus 1. Stop that, please. Leave it on your desk, please. Could you? Don't move this. I know it's not you. Okay, what do you do now, guys? What do you do now? Come on, guys. Distribute the property. 5x plus 5 plus 2x minus 2 equals negative 6 times x squared. Oh, minus 1. Oh, that's the difference of squares, isn't it? Negative 6, guys. Why would it switch from a negative 6 to a t? So 5x, well here, I'll just do the whole line here. Plus 2x minus 2 equals negative 6x squared plus 6. Yeah, you can if you want. I'm just doing it all in one line because somebody's going to ask me where those numbers came from. So I'm doing every single step. Oh, I'm just doing every single step because somebody's going to ask it. So it's just easier. Now, can you collect like terms? And make it equal to what? 0. More than likely, you're going to make it equal to 0. Sure, why not? So the 6x negative 6x squared comes over, it becomes 11x squared.
Oh, how does it become 11?
Oh, sorry, that's not an x squared. Sorry. Positive, 6x squared. Bring the... Oh, it's already there. So 7x. 5 minus 2 is 3. Bring the 6 over is... Negative 3 equals 0. Is that correct? Now, you look at that. If you can't factor that, you'd have to use quadratic.
You can pass that.
Of course you can.
Is there going to be any quadratic equation?
Of course there is. 6x squared. Either 1 or 6 or 2 or 3.
2 or 3.
Now, you might have to do a little trial error, but 2 and 3 should work. So 2 and 3. The only two factors of 3? 3 and 1. We want it to equal 7, so where does the 3 go? It has to go with here because 3 times 3 is 9, minus 2 is 7. Okay. We want the sign to be positive, so the positive goes to go with the 9. There's your negative. Did you double check that? Yeah, you just FOIL it to see if you did it correctly. Shouldn't get it wrong because you have a chance to FOIL it.
You don't need it like that. You're already done.
We're not done. We're solving for x. What's x? You got to make each side equal to 0. You guys realize those are just zeros, x-intercepts, right? Didn't we do this all before? Yeah, we did all this stuff. It hasn't changed any of this stuff. It's just how we apply it, right? So 2x plus 3 equals 0. 3x minus 1 equals 0, right? It's all the same stuff we've been working on for the last 2 months. Hasn't changed. What does x equal? X equals negative 3 over 2, is that right? And x equals 1, 3. Now, could both of those be answers? Yes. Why not? Why? They're not NPVs. What are our NPVs? Plus or minus 1, right? So those don't apply. So those could be 2 answers. Yeah. Yeah. Extraneous root. Right. Right. So for instance, guys, let's say, just for a side note. So let's say this is negative 3 over 2, but let's say over here we got this, don't write this down, we got that to be 1. What would you call that one then? You'd call that an extraneous root because it's one of the NPVs. Stop that, please. You'd call that an extraneous root. Okay, does that make sense? All right, next question. Actually, skip that question. Go right to 7. No, just go to 7, please. Will there be one of these on the test? Yes, there will be. I just said that. You guys need to listen, please.
Wow.
We won't have it on the test. Oh,
There's better not be a 6 on the test.
you're going to put it on the test?
Just Blake's test. I'll put it on there.
Do you see that?
Don't put it on the board.
Paul, did you type out 8? Why is my paper different?
Yeah.
No, look at mine.
Yeah.
Because one is Smartboard and then one is Word. They don't transfer properly. It's actually a real pain in the butt when you do the guys, you can figure it out, can't you? Then quit your whining. Okay. So what we have here, guys, is we have a rectangle. And I mean in the past, when we were talking grade 9, right, we gave you stuff like the length would be 7 and the width would be 5, and then we'd ask you a bunch of questions. What's the perimeter? What's the area, right? No, it's not. Because it's still the same principle as it was in grade 9. Just hang on. The only difference is, instead of numbers, we have rationals. That's it. That's the only difference. Well, what are the rules? How do you find the perimeter of a rectangle? The perimeter of a rectangle. You add up all the sides. How do you find the area? Length times width. Well, do we know how to add rationals? Do we also know how to multiply rationals? So how is this any different than what we've done? No, it just looks difficult. It's not.
So, is this question going to be on the test?
Yes.
No. How we just have no word?
How about I just give you 100% and we all go for cake and ice cream?
Yeah.
That is not going to happen. I mean, come on.
Or, like, if it's, like,
Okay. What is, write an expression for the difference between the length and the width. Difference. What's that mean? Minus. Between the length and the width. Okay. So basically what we're talking here, guys, is we're taking length and we're minusing width. Isn't that what we're saying? Which one of these is the length? So that's the length. Which one of these is the width? Okay. So could you write me an expression that takes the length and minus the width? What would it be?
3 minus x over x squared
Minus 2 over x. Okay. Is that correct so far? Did we just take the difference between the length and the width?
With the expression, we don't have to say no.
No, because it doesn't say an equation. It just says an expression, right? Expression is like when we add or subtract. That's it. If it's an equals, then we're solving, right? Which is going to be, what we're going to be is like that's the C, right? Where we're going to make it equal to something we have to solve. Okay? Okay, now, the next part of this says what? Simplify your answer. So does that mean
Common denominator.
LCD, find one that's the same, and simplify. Okay, we have an x squared and we have an x. Would x cubed work? Yes, it would. It's not.
Yeah.
X cubed would work. Is it the lowest one? No. So what's our LCD in this case? X squared. So our LCD
Wait.
is
Good question. Why can't it be x?
because x squared does not go into x. Each one has to be able to divide into it. So x divides into x, but x squared does not divide into x. It has to be the larger of them. That's why I asked you if x cubed would work. Okay, so we want our common denominator to be, what do we want it to be? X squared. So what do we need to do to the first one?
Leave it alone.
You leave it alone. You don't even have to touch it because it's already in the form x squared. What about the second one? What do we got to times this 2 by? We got to times it by x. So what do we end up with? Negative 2x, right? We have to times it by x. The first one we don't have to touch because it already has the denominator of x squared. The second one we have to times by x, right? Top and bottom, because whatever we do to the bottom, we do to the top. Basic rule of fractions, right? Now what do? Collect like terms. So 3 minus 3x over top of x squared. Is we collected like terms? What? You don't need to. Collect, please. That's it. You simplified the expression. Now we need to do B and C. Okay, B asks, what does B ask? Hey, what is the expression for the area of a rectangle? And what is area? Length times width. Okay. Do we know what length and width are?
Yeah.
Length is?
3 minus x over x.
So 3 minus x over x squared times 2 over x. Okay. No. Why do you think you need to find an LCD? Are you solving for anything? No, you're not. This is where, because you're multiplying, you can actually do some simplification on the fly, right? You can cancel stuff because it's multiplication. Let's just multiply this. What do we get when we multiply this? Six minus 2x. So 6 minus 2x over top of x cubed. Okay. Distributive property, 2 times both of those, right? You see how the rules are all there. They haven't changed. Can't you simplify anymore? Well, I hear yes and I hear no.
No, you not.
Why not? Okay, this is what she thinks she can do. Oh, hang on.
You already said it.
So you said take all those x's and do that to them, right? And then you said do what? Oh, but wait. If you cancel out of this one, you also have to cancel out of this one. Why? Because the minus. So can you do that? No. Okay, is that in simplest form? Yes, it is. But thank you. You did realize that after you said it, right? That's some good learning. That's some good schooling you got there. Okay. No, you cannot. Why would you? No, you can't. There's no negative 2 out of here. Oh, that doesn't make any difference. Okay, last one. C. If the perimeter of the rectangle is 28, find any value or bracket values of x. Okay. How does that confuse you? There are 2 possible ways to look at this question. What? No. You have to think what perimeter is. Perimeter is the distance around an object, right? Okay, hang on. This is the 2 ways of thinking about it. You could look at it this way. You could say perimeter equals, right, 2 times L plus 2 times W. Is that correct? Or could you just have perimeter equals L plus W plus W? Does that work? Does either one work? Does it matter to me which way you do it? This one sounds more easier?
Yeah, it's just...
Okay, we're gonna more easier this one because it's more easier to do. Yeah, of course, it's recording everything. But.
I'm failing English, okay?
Okay, hang on. So let's start with what we know. What's the perimeter? 28. Okay, so 28 equals 2. What's L? What was it again? 3 minus x over x. Okay. Plus? Thank you. Plus, what's the width? 2 over x. This is back to the question we did just before this question. Not the A or B part. I'm actually talking about the question before that. The solving for x one. Right?
I don't like it.
Well, it doesn't matter whether you like it or not. It's really quite simple. The key is, guys, if you're solving for x in a case like this, what are you trying to get rid of? The denominator. You'll get rid of the bracket potentially. You're trying to get rid of the denominator. So what do you need to find? An LCD. What is our LCD in this case? It's x squared. Okay, now, can I take each piece and times it by x squared? Yeah. Now we're going to have some double brackets in here, but who cares? By the time we're done, it'll cancel everything out. So, yeah, okay, let's do our NPVs there. What's our NPVs, by the way? NPVs, x cannot equal 0, right? No. Okay. Okay, so let's take each piece here, guys. Each chunk, and I'm just doing a different color on the board here so you can see what I'm timesing it by. I'm going to take each one and multiply it by what? X squared. X squared. X squared. That's all I'm doing. Okay?
Okay. Just what you're doing.
All you do there.
28 times x squared. Well, that's tough. What happens to these x squareds on this one? They're gone, right? That one's gone. That one's gone. What are you left with? 2 times 3 minus x, right? Is that correct? Can we do that? Could we actually FOIL that? Okay, what's 2 times 3? 6. 2 times negative x? Negative 2x. Yeah? Really not that bad, is it?
Weird.
Yeah, it is. But that's why I picked it this way, right? Because you're not always going to see stuff forwards, right?
If I can see it, can I switch?
Take the whole thing and flip it around? Yeah, if you want. So make it equal to 28, right? So in that case, you'd have 2L plus 2W equals P, right? Equals 28. That's fine. Okay, what about here? What cancels here? One of that one and one of those ones. Careful, because you still have the 2x. So you have x times 2 times 2. 4x plus 4x. Make it all what? Yeah, you could. Okay, so now the thing you're going to look at, and this is one of two ways. If there's an x squared in there, like there is, more than likely you make it equal to 0 because you could probably factor it into two binomials. If there was no x squared there, you just put the constants on one side and the x's on the other. That's just basic algebra, right? Right? If there's no x squared there, it's just basic algebra. Okay. So let's collect everything. Let's all make it to 0. We might as well bring it all over to this side. So 28x squared plus, oops, I'm moving it all to the left side. Negative 2x plus that is positive 4 comes over, it's negative 2x. Minus 6 equals 0. What do you do?
Quadratic.
Both of you.
Why do I take over 2 versus...
Hey, that's a good start. Come at me, bro. Why do you want to take out a 2? Yeah, GCF, guys. Now, you guys, you can't miss that, right? Don't try to factor it right away into two binomials. Always see if there's a GCF. Always, 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 always. 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 You take out a 2. So what do we end up with? 14x minus x minus 3 equals 0. What do you mean, now what? Factor! Give it a shot! If it doesn't factor, then you have to use quadratic. Oh, don't give me, just because it's a 14, that's not, don't be scared. There's only 4 factors of 14. 1 in 14 and 2 in 7.
2 and 2 and 7. So let's take 2 and 7.
Why not? And if it doesn't work, we'll try the other ones. Big deal. Oh, what about 3? How many factors of 3 are there? 1. 1 and 3. That would be 2, Blake. And we want the combination in the middle to equal 1. So 1 and 3. What's 2 times 3? 1 times 7? 7 minus 6? That's our combination. Now we just have to figure out the signs. We want it to be negative, so the bigger has to be negative. So this is our negative 7 and our plus 3. Negative 7 plus 6 gives us our negative 1. Easy.
40 pushes.
Okay, now what do you do?
That's squared.
Yeah, well, you could FOIL it into check, right?
You should ask for an x, whatever it is.
Yeah, you gotta find out what x is, right? So do you make each side equal to 0?
Yeah.
Yeah, this is like the x-intercepts of the root, right? Because basically, I don't know if you figured this out. Every time we do one of these questions, it always ends up as being a quadratic, right? Could you actually do it on your TI-83 and check your answer too? Yeah, you could. You could graph and find your intercepts. Okay, so so 2x minus 1 equals 0. 7x plus 3 equals 0. X equals a half. X equals negative 3 over 7.
What's that do there for?
For this? Don't get it right.
What's the answer? What's the answer, guys?
Take 2 seconds, 1x.
What? Can you have negative distance? So what's the negative 3 over 7 then? Extraneous root. Oh, very nicely done, by the way. So that negative 3 over 7, right? That negative 3 over 7, that thing right there, right, is an extraneous root. Because it's negative. You can't have negative distance. Why do we have that number there in the first place then anyway?
To do the math.
Yeah, we needed to do the math, right? We needed to do the calculations, but sometimes it comes up as an extraneous root. You're going to see a lot of that through 11 and 12. You'll see extraneous roots. Okay. So what? Well, whatever the units are. What were the units on this one? I don't think there's, centimeters, right? So x is a half, right? So what's 2 divided by half? Times, so it'd be 4, right? So the width would be 4. This would be 3 minus a half over a half. That's like you could actually calculate it out. Just plug it in. So, guys, quiet, please. Quiet. You just check your answer, right? Because then you could check, once you have the length and the width, you could add them up and see if you get 28, right? All right.